Welcome to Academic Game Tutorials. In this operations research lecture series, the topic for today's lecture is Simplex Method. In the previous lecture we have seen how to solve a maximization problem using Simplex Method, and, in today's lecture, we will solve this minimization problem using Simplex Method. Before we get into the solution, if you haven't subscribed to this channel yet, just click on subscribe, and make sure to watch the full video to get a clear concept of this topic. So, let's start solving the problem. Now, this linear programming problem is given to us in general form. To solve this using Simplex Method we have to convert it into standard form at first. Here we can see three constraints with three less than equal to signs. To convert these three unequal constraints into equations, we have to introduce three slack variables. Now, at step number 1, by introducing slack variables S1, S2, and S3, we will convert the problem into standard form. As we can see here in the question, this is a minimization problem, so we have to change the objective function from minimization problem to maximization problem. So, for the standard form, we will write the objective function as max z dash equals to, then on the right hand side, we will multiply all expressions by -1 and write minus x1 plus 3x2 minus 2x3. Now, we will introduce these three slack variables S1, S2, and S3 in these three unequal constraints, and turn them into equations in standard form. So, for the first equation, we will write, subject to 3x1 minus x2 plus 2x3, then add the slack variable S1, equals to 7. For the second equation, we will write, minus 2x1 plus 4x2, then add the slack variable S2, equals to 12. For the third equation, we will write, minus 4x1 plus 3x2 plus 8x3, then add the slack variable S3, equals to 10. Here we have less than or equal to sign, so we introduced these three slack variables S1, S2, and S3, and converted them into equations in standard form. In graphical method we would just convert from unequal form to equation form using equal sign. We would not need to use any variables, but in Simplex Method, we have to use slack variables. Again, here we can see that the decision variables x1, x2, and x3 are all greater than or equal to 0, so, all the conditions to convert the LPP from general form to standard form are fulfilled. Earlier, we explained in details with example to convert from general form to standard form step by step in lecture number 5. Now, since we have introduced the slack variables S1, S2, and S3 in our equations, we also have to write S1, S2, and S3 in the objective function over here. So, in the objective function we add 0s1 plus 0s2 plus 0s3. As we know that the cost of slack variable is 0, we have written 0 before them. And, below the constraint equations we will write x1, x2, x3, s1, s2, s3, greater than or equal to 0. So, we have converted the problem from general form to standard form at first. Now, for the second step we will find the initial basic feasible solution. If we see here, we have 6 decision variables now. The decision variables x1, x2, and x3 were given in the problem, and we introduced the other 3 variables, s1, s2, and s3. The value of the decision variables that were given in the problem will be 0, so we will write x1 equals to x2 equals to x3 equals to 0. Then, we have to find out the values of s1, s2, and s3. Now, in these constraints we can see, if the values of x1, x2, and x3 is 0, then, from the first one, the value of s1 will be 7, from the second one, the value of s2 will be 12, and from the third one, the value of s3 will be 10. So, our second step is done. Now, in the third step we will write the standard form LPP into matrix form. So, A into X equals to B is the matrix form, and we have to write this standard linear programming problem into this matrix form. Now, if we take a look at the constraints here, the cost of x1 is 3, the cost of x2 is -1. Similarly, the cost of x1 over here is -2, as we can see the cost is written in front of x1. So, in the matrix form, the letter A represents the cost of these 6 variables. Again, the letter X in the matrix form represents these 6 variables. And the letter B in the matrix form represents the values we have here in the right-hand side. So, let's write this standard form LPP into matrix form. In the headings, at first here we have written all the variables, x1, x2, x3, s1, s2, and s3. Now, we will put the cost or the values of these variables from this standard LPP. Here we can see that, for the first constraint equation, the value of x1 is 3, the value of x2 is -1, the value of x3 is 2, and the value of s1 is 1. So, we put the values 3, -1, 2, and 1 over here, since the first constraint equation does not have s2 and s3, so the value of s2 and s3 is 0. Similarly, for the second constraint equation, the value of x1 is -2, the value of x2 is 4, there is no x3 here, so the value of x3 is 0, there is no s1 here, so value of s1 is 0, the value of s2 is 1, and since there is no s3 here, so value of s3 is 0. And for the third equation, the value of x1 is -4, the value of x2 is 3, the value of x3 is 8, there is no s1 and s2 here, so value of s1 and s2 is 0, and the value of s3 is 1. So, we have written the values of A in the matrix form. Now, for the values of X in the matrix form, we will write all the variables over here as the value of X. So, we have written all the variables x1, x2, x3, s1, s2, and s3 as the value of X. And, finally on the right-hand side, we will write these values from the equations 7, 12, and 10. These are the values of B in the matrix form. So, in this step, we have written the standard LPP into the matrix form. Now, in the next step, we have to construct the initial simplex table. So, here we can see an initial simplex table. You have to make an initial simplex table exactly like this one, and remember to leave some space on the right-hand side of the table. We will use this space later. Now, the first row on the table is for Cj. To fill up this row for Cj, we will take a look at the objective function. Here, in the objective function we have 6 variables, x1, x2, x3, s1, s2, and s3, and in front of each variable there is the cost of these variables, -1, 3, -2, 0, 0, and 0. We will write the cost of these variables from objective function to fill up the row for Cj over here. So, we have written the costs, -1 for x1, 3 for x2, -2 for x3, 0 for s1, s2, and s3. So, this row has been filled. Now, we will fill up the columns. The column B over here is the column for basic variables. When we will make the first initial table, the slack or surplus variables that we introduced into the problem earlier will be written in this column B. So, here we can see that we have 3 slack variables. So, in the column B we will write the 3 slack variables, s1, s2, and s3. And the column CB over here is for the cost of these basic variables in column B. So, the cost of s1 is 0, the cost of s2 and s3 are also 0. Since this is the initial simplex table, the basic variables we write in this column B are all slack variables, and we already know that the cost of slack and surplus variables is 0. So, the value of CB will be 0 at first for all variables in the initial simplex table. Now, in the column XP over here, we will write the values from the right-hand side of the matrix form. 7, 12, and 10 are the values on the right-hand side. If you haven't made the matrix yet, you can take the values from right-hand side of these equations also. So, in the column XP we write the values from right-hand side of the matrix, 7, 12, and 10. Now, we have to fill up this region. We will put the values of the variables for these rows directly from the matrix over here. In the first row we have 3, -1, 2, 1, 0, and 0. In the second row we have -2, 4, 0, 0, 1, and 0. And in the last row we have -4, 3, 8, 0, 0, and 1. The initial simplex table is now ready. Now, we will calculate the values of Zj minus Cj. In the initial simplex table, we have a row down here. This is the row for Zj minus Cj. For the calculation of Zj minus Cj, the general formula is Zj minus Cj equals to Cb into Xj minus Cj. Now, since this is the initial simplex table, we know that the basic variables we write in this column B are all slack variables, and we already know that the cost of slack and surplus variables is 0, so the value of Cb is 0 in the initial simplex table, and here in the general formula, the value of Zj is Cb into Xj, since Cb is 0 in the initial table, so 0 into Xj is 0. Thus the value of Zj in the initial table will be 0. So, in the initial table, the value of Zj minus Cj will be minus Cj. This will happen only in the initial simplex table, because only in the initial table all the values of Cb will be 0. Now, based on this general formula, for the calculation of Z1 minus C1, the formula will be Z1 minus C1 equals to Cb into X1 minus C1. Now, we have Cb into X1, the value of Cb is 0, 0, and 0, and the value of X1 is 3, minus 2, and minus 4, so the value of Cb into X1 will be 0 into 3, which gives us 0, plus 0 into minus 2, which gives us 0, plus 0 into minus 4, which also gives us 0. So, Cb into Xj is 0 as we have seen here. Then we will give the minus sign and subtract C1. The value of C1 is minus 1. Thus, value of Z1 minus C1 will be 1. So, whatever value of Zj minus Cj we get in initial table will be actually the value of minus Cj. So, since it is the initial simplex table, we will simply multiply all the values of Cj by minus 1 and write the values in Zj minus Cj row. So, minus 1 will become plus 1, 3 will become minus 3, minus 2 will become plus 2, and these 3 will remain 0, 0, and 0. So, we have found out the values for Zj minus Cj. Now, all the values of Zj minus Cj are not greater than or equal to 0. Here we can see a negative value of Zj minus Cj, which is minus 3. We will indicate this negative value of minus 3 by an arrow. If there were 2 or more negative values of Zj minus Cj, we would select the most negative value among them. Since here we have only one negative value, so we have selected this one. We indicated this negative value of minus 3 by an arrow, and this corresponding column will be the key column. The variable x2 will be the incoming vector. So, the incoming vector x2 will enter this basic variable column in the next table, but at which position will x2 enter? Will x2 enter in the position of S1, or S2, or S3? To find out at which position this incoming vector will enter this basic variable column in the next table, we have to find out the minimum ratio. Now, on this side we will make a column for the calculation of minimum ratio. The formula for minimum ratio is xp divided by the key column, and the value of key column has to be greater than 0. Here, the key column is x2, so we will divide the values of column xp by the values of key column x2 for calculating minimum ratio. For the first row, xp is 7, and value of x2 is minus 1. Since the value of the key column is minus 1 in this row, we will not calculate the minimum ratio for this row. because we said earlier that the value of key column has to be greater than 0, it cannot be 0 or less than 0. For the second row, xp is 12, and value of x2 is 4, so we divide 12 by 4, the minimum ratio will be 3. Now, for the third row, xp is 10, and value of x2 is 3, so we divide 10 by 3, the minimum ratio will be 3.33. Now, between these two values 3 and 3.33, the minimum value is 3. We will indicate this minimum value of 3 by an arrow, and this corresponding row will be the key row. This variable s2 will be the outgoing vector. So, in the next table, this outgoing vector s2 will leave this place, and this incoming vector x2 will take the place of this outgoing vector s2. And this common element between this key row and key column is called key element. Here, 4 is the common element between key row and key column, so 4 is the key element. Now, we have to construct the new simplex table by entering incoming vector. So, moving forward, here we have made a new simplex table. In the heading we have written first iteration. So, this is the first iteration simplex table. We have constructed this new simplex table exactly like the first table. Now, the value of cj row will remain same, because the objective function is same, and the cost of the objective function has remained same. So, we will copy and write the value of cj from the table number 1 to this new table. Here we will write -1, 3, -2, 0, 0, and 0, as the cost will remain same. In the basic variable, in the first table we had s1, s2, and s3. Here, s2 is the outgoing vector, and in place of s2, the incoming vector is x2. So, in place of s2, we will write x2. Here we have written the basic variables, s1, x2, and s3, so, we have replaced s2 by x2. Now, we will write the cost of these variables here, so, the cost of s1 is 0, the cost of x2 is 3, and the cost of s3 is 0. Now, starting from xp, we have to fill up the rest of this table by doing some calculations. In the initial table, we filled up the values very easily by looking at the metrics, but in this second table, we have to do some calculations to fill up the remaining values, and we will do the calculations by looking at table number 1. If you observe carefully, in table number 1, the basic variables were s1, s2, and s3. If you observe the values of s1 column here, we have 1, 0, 0. In the s2 column here, we have 0, 1, 0. And in the s3 column here, we have 0, 0, 1. So, this forms an identity matrix. The basic variables are written serially as s1, s2, and s3. And if the s1, s2, and s3 columns are arranged in the same serial, we get an identity matrix like this. Now, in the table 2 also, the basic variables are s1, x2, and s3. If the s1, x2, and s3 columns are arranged in the same serial, we should get an identity matrix. Now, 4 is the key element here. This key element has very important role in doing the calculations. Now, this key element is in second row, so we will divide all the values of the second row by this key element. In other words, we will divide all elements of the key row by the key element. So, the operation will be r2 equals to r2 divided by 4. Here, 4 is the key element, and, as we said earlier, our motive is to replace or convert the key element into 1 in the new table, so that it forms identity. So, in the new table, we have to obtain 1 in this position, and in the other two positions of this key column, we have to obtain 0 and 0. If we check here, s2 was the outgoing vector. In the s2 column here we had 0, 1, and 0. In the second table, incoming vector x2 will take the place of outgoing vector s2. So, we have to ensure that the value of x2 column will be 0, 1, and 0, just like the old s2 column. For this reason, at first we will divide the r2 row by the key element 4, because if we divide 4 by 4, we will get 1 in this position. So, the operation will be r2 equals to R2 divided by 4, we will divide all elements of R2 row by 4 to get the new R2 row. So, when we divide 12 by 4, in the new table we will write 3 in the place of 12, then we will get -1 by 2, 1, 0, 0, 1 by 4, and 0. You can also check for yourself by dividing all the elements of R2 by 4, these values will be obtained in the new row R2-. So, in the new table, the second row is filled up. Now we will fill up the first row. So, to fill up the new R1 row, the operation will be R1- equals to R1 plus R2-. To fill up the new row R1-, we will take help of the new R2- row. Here R2 is the second row of previous table. We used R2 to make the new R2- row in this new table. Now we will use R2- row from new table and R1 row from previous table to get the new R1- row in table. So, in the row operation we have written R1 and R2-. Now, why are we adding them? As we said earlier, we have to perform some operation, so that the value of this position in the new table becomes 0. In R1 row of the old table, in this position we had -1, and in the new R2 row we have obtained +1 in this position. Now if we add this old R1 row and new R2- row, then -1 plus +1 will be 0. So, in the new R1- row, we will get 0 in this position. This is why we are adding R1 row with R2- row. So, let's see in rough. Here, we will write the value of R1 from the old row, 7, 3, -1, 2, 1, 0, and 0. We will write the value of R2- row from this new table, 3, -1 by 2, 1, 0, 0, 1 by 4, and 0. Now, we will add R1 and R2-. We get 10, 5 by 2, 0, 2, 1, 1 by 4, 0. So, this is the value of R1-. We will fill up this first row with this value. Next, we have to find out R3-. For that we have written R3 and R2-. We have to make an operation between old R3 row and new R2- row to get the values for R3- row in new table. If we look in the R3 row of the previous table, here, this element 3 has to be converted to 0 in this position in the new table. So, here we have 3, and here in R2- we have 1. So, if we multiply 1 with 3, we will get 3. Then if we subtract that 3 from this 3 of the old row, we will get 0 in this position. So, the operation will be R3 minus R2- multiplied by 3. We will multiply R2- by 3, then subtract from R3. So, let's see in rough. Here, we will write the value of R3 from the old row, 10, -4, 3, 8, 0, 0, and 1. We will write the value of 3 R2- from this new table, so, we will multiply all elements of R2- row by 3, and write here, 9, -3 by 2, 3, 0, 0, 3 by 4, and 0. Now, we will subtract 3 R2- from R3, we get 1, -5 by 2, 0, 8, 0, -3 by 4, 1. So, this is the value of R3-. We will fill up this third row with this value. In the lecture number 6, we have seen two methods of forming this table. In this table we did some row operations for calculating the values to fill up the table. In the other method that we have seen earlier, we would cross-multiply the old values to get new values. For example, let's find out the value for this position. In the table number 1, in this position we have 3. So, we go to table number 1, then we will directly cross-multiply 3 with the key element. Here the key element is 4, and then, we can see that here we have -2, and here we have -1. If we multiply -2 and -1, it will form a cross diagonally. We multiplied 3 with 4, and we will multiply -2 with -1 over here, so it will be a cross multiplication. So, in calculation we will write 3 multiplied with 4, minus -2 into -1. Then we will divide this whole thing by the key element. Here the key element is 4, so we divide the whole expression by 4, and finally we will get a value of 5 by 2. We were finding this value for this position, so we will write 5 by 2 in this position. So, in the second method also we got the same value for this position. You can either use the first method, or this second method, whichever seems easier to you. So, we have prepared the simplex table for the first iteration. We have filled all the values in this first iteration table. Now, we will find out the values for zj minus cj and fill up this last row. Remember that this is not the initial table, so in this table we cannot directly write minus cj as the value of zj minus cj. The general formula is zj minus cj equals to cb into xj minus cj. We have to calculate the values for zj minus cj by using this formula. For the calculation of z1 minus c1, the formula will be z1 minus c1 equals to cb into x1 minus c1. Here we have to multiply cb with x1, so 0 into 5 by 2 plus 3 into minus 1 by 2 plus 0 into minus 5 by 2. Now, here we write 0 into 5 by 2 plus 3 into minus 1 by 2 plus 0 into minus 5 by 2, then give the minus sign from formula, and in the cj row, we can see the value of c1 is minus 1, so we write minus 1 here, and finally, the value of z1 minus c1 will be minus 1 by 2, so in this row, here we will write minus 1 by 2. Now, for a quick technique, if you see here, the value of cb is 0, and here also the value of cb is 0, so we don't actually need to calculate for these two values of cb, because they are 0. If we multiply anything with 0, then it will be 0. If we are calculating for z2 minus c2, then we have to multiply 0 with 0, and here also 0 multiplied with 0, the result will be 0. For z3 minus c3, we have to multiply 0 with 2, and here also 0 multiplied with 8. The result will be 0 for both. Similarly, for calculating z5 minus c5, we have to multiply 0 with 1 by 4, and here also 0 multiplied with minus 3 by 4. The result will be 0. So, for quick calculation, we will notice which values of the CB column are 0. Here we have 2 zeros in CB column, so we don't have to calculate for 0, we will only calculate for 3. Here, 0 into 0 will be 0, 3 into 1 will be 3, minus Cj. Here value of Cj is 3, so 3 minus 3 will be 0, so the value of Z2 minus C2 will be 0. Again, 3 into 0 will give us 0, minus Cj. Here value of Cj is minus 2, so minus of minus 2 will be plus 2, so the value of Z3 minus C3 will be 2. Similarly, 0 into 1 will be 0, 3 into 0 will be 0, and 0 into 0 will be 0, minus Cj. Here value of Cj is 0, so 0 minus 0 will be 0, so the value of Z4 minus C4 will be 0. Here also, 3 into 1 by 4 will be 3 by 4, minus Cj. Here value of Cj is 0, so 3 by 4 minus 0, so the value of Z5 minus C5 will be 3 by 4. Again, 3 into 0 will be 0, minus Cj. Here value of Cj is 0, so 0 minus 0, so the value of Z6 minus C6 will be 0. So, we have found out the values for Zj minus Cj and filled up this row. Now, all the values of Zj minus Cj are not greater than or equal to 0. Here we can see a negative value of Zj minus Cj, which is minus 1 by 2. We will indicate this negative value of minus 1 by 2 using an arrow, and this corresponding column will be the key column. The variable x1 will be the incoming vector. So, the incoming vector x1 will enter this basic variable column in the next table, and to find out at which position this incoming vector will enter this basic variable column in the next table, we have to find out the minimum ratio. Now, on this side we will make a column for the calculation of minimum ratio. The formula for minimum ratio is xp divided by the key column, and the value of key column has to be greater than 0. Here, the key column is x1, so we will divide the values of column xp by the values of key column x1 for calculating minimum ratio. We did not make these column for minimum ratio at first, because after finding these values of zj minus cj, if we found out that all the values are greater than or equal to 0, then we would reach the optimum solution stage, and we would not have to calculate minimum ratio, so we would not make the minimum ratio column. But here we have a negative value of zj minus cj, so we didn't reach the optimum solution stage yet. We have to make another new iteration table, so we need to calculate the minimum ratio. Thus we made the minimum ratio column now. So, for the first row, xp is 10, and value of x1 is 5 by 2, so we divide 10 by 5 over 2, the minimum ratio will be 4. For the second row, xp is 3, and value of x1 is minus 1 by 2, since the value of the key column is minus 1 by 2 in this row, which is a negative value, so we will not calculate the minimum ratio for this row, because we said earlier that the value of key column has to be greater than 0, it cannot be 0, or less than 0. Now, for the third row also, the value of the key column is minus 5 by 2 in this row, which is a negative value, so we will not calculate the minimum ratio for this row also. So, we got only one value for minimum ratio, so this will be our minimum value. We will indicate this minimum value of 4 by an arrow, and this corresponding row will be the key row. This variable s1 will be the outgoing vector. So, in the next table, this outgoing vector s1 will leave this place, and this incoming vector x1 will take the place of this outgoing vector s1. And this common element between this key row and key column is called key element. Here, 5 by 2 is the common element between key row and key column, so 5 by 2 is the key element. Now, we will make the second iteration table. So, here we have the simplex table for second iteration. The value of cj row will remain same, because the cost of the objective function has remained same. So, we will copy and write the value of cj from the previous table to this new table. Here we will write minus 1, 3, minus 2, 0, 0, and 0, as the cost will remain same. We will take help from the previous or the first iteration table to calculate values for this second iteration table. We are making the third table, so we will take help from this second table. In the basic variable column, in the first iteration table we had s1, x2, and s3. Here, s1 is the outgoing vector, and in place of s1, the incoming vector is x1. So, in place of s1, we will write x1. Here we have written the basic variables, x1, x2, and s3, so, we have replaced s1 by x1. Now, we will write the cost of these variables here, so, the cost of x1 is minus 1, the cost of x2 is 3, and the cost of s3 is 0. Now, we have to fill up the rest of this table by doing the calculations. We will take help for calculation from the first iteration table, and here also, we have to convert the key element into 1. Here, the key element is 5 by 2. We have to obtain 1 in this position in the new table. The other two elements in this key column are minus 1 by 2 and minus 5 by 2. We have to obtain 0 in these two positions in the new table. Because, if we check here, s1 was the outgoing vector. In the s1 column here we had 1, 0, and 0. In the second table, incoming vector x1 will take the place of outgoing vector s1. So, we have to ensure that the value of x1 column will be 1, 0, and 0, just like the old s1 column. So, at first, if we multiply this row r1 with 2 by 5, then this key element will be converted to 1. So, for the new table, the row operation for the first row will be r1 dash equals to r1 multiplied with 2 by 5. We have to multiply all elements of old r1 row with 2 by 5 to obtain this new first row, which is r1 dash. So, 10 into 2 by 5 will be 4, 5 by 2 into 2 by 5 will be 1. Similarly, we will get 0, 4 by 5, 2 by 5, 1 by 10, and 0. So, we have filled the first row, r1 dash. Now, we have to fill the second row, R2 dash. To calculate R2 dash, we have to take the R2 row from the previous table, and R1 dash from this new table. Then we have to do a row operation between R2 of previous table, and R1 dash from this new table, so that we get 0 in this position. So, we have to obtain 0 in this position in new table. So, here we have minus 1 by 2. If we can add plus 1 by 2 with this, then we will get 0. For that we will take help from R1 dash row in new table. If we divide R1 dash row by 2, here we will get plus 1 by 2, then we will add with R2. So, the row operation will be R2 plus R1 dash divided by 2. So, let's see in rough. Here, we will write the value of R2 from the old row, 3, minus 1 by 2, 1, 0, 0, 1 by 4, and 0. We will write the value of R1 dash by 2. From this new table, we will divide all elements of R1 dash row by 2, then write here, 2, 1 by 2, 0, 2 by 5, 2 by 10, 1 by 20, and 0. Now, we will add R2 and R1 dash by 2, we get 5, 0, 1, 2 by 5, 2 by 10, 3 by 10, 0. So, this is the value of R2 dash. We will fill up the second row with this value. Next, we have to find out R3 dash. For that we have written R3 and R1 dash. We have to make an operation between old R3 row and new R1 dash row to get the values for R3 dash row in new table. If we look in the R3 row of the previous table, here this element, minus 5 by 2, has to be converted to 0 in this position in the new table. So, here we have minus 5 by 2. If we can add plus 5 by 2 with this, then we will get 0. For that we will take help from R1 dash row in new table. If we multiply R1 dash row with 5 by 2, here we will get plus 5 by 2, then we will add with R3. So, the row operation will be R3 plus 5 by 2 R1 dash. So, let's see in rough. Here, we will write the value of R3 from the old row, 1, minus 5 by 2, 0, 8, 0, minus 3 by 4, and 1. We will write the value of 5 by 2 R1 dash from this new table. So, we will multiply all elements of R1 dash row with 5 by 2, and write here, 10, 5 by 2, 0, 2, 1, 1 by 4, and 0. Now, we will add R3 and 5 by 2 R1 dash. We get 11, 0, 0, 10, 1, minus 1 by 2, and 1. So, this is the value of R3 dash. We will fill up this third row with this value. So, we have filled up the values for this second iteration table. If you observe carefully, in this table, the basic variables are x1, x2, and s3. If you observe the values of x1 column here, we have 1, 0, 0. In the x2 column here, we have 0, 1, 0. And in the s3 column here, we have 0, 0, 1. So, this forms an identity matrix. The basic variables are written serially as x1, x2, and s3. And if the x1, x2, and x3 columns are arranged in the same serial, we get an identity matrix like this. So, after filling up the table, we should always check that an identity matrix form like this is created or not, so we can understand that all values are right or not in the table. An identity form is created in this table, so the values are correct here. Now, we will find out the values for zj minus cj and fill up this last row. We will find out the values for zj minus cj using this formula just like we did for the initial table. The general formula is zj minus cj equals to cb into xj minus cj. For the calculation of z1 minus c1, the formula will be z1 minus c1 equals to cb into x1 minus c1. Here we have to multiply cb with x1, so minus 1 into 1 plus 3 into 0 plus 0 into 0. Now, here we write minus 1 into 1 plus 3 into 0 plus 0 into 0, then give the minus sign from formula, and, in the Cj row, we can see the value of C1 is -1, so, we write -1 here, and finally, the value of Z1 minus C1 will be 0, so, in this row, here we will write 0. Now, in the same way we will find out value of Z2 minus C2. The formula will be CB into X2 minus C2. Here we will have -1 into 0 plus 3 into 1 plus 0 into 0 minus the value of C2 is 3, and finally the value of Z2 minus C2 will be 0, so in this row here we will write 0. Now, in the same way we will find out value of Z3 minus C3. First multiply CB into X3. Here we will have -1 into 4 by 5 plus 3 into 2 by 5 plus 0 into 10 minus the value of C3 is -2, and finally the value of Z3 minus C3 will be 12 by 5. So, in this row, here we will write 12 by 5. Similarly for Z4 minus C4, here we will have -1 into 2 by 5 plus 3 into 1 by 5 plus 0 into 1 minus the value of C4 is 0, and finally the value of Z4 minus C4 will be 1 by 5. So, in this row, here we will write 1 by 5. For Z5 minus C5, here we will have -1 into 1 by 10 plus 3 into 3 by 10 plus 0 into -1 by 2 minus the value of C5 is 0, and finally the value of Z5 minus C5 will be 4 by 5. So, in this row, here we will write 4 by 5. And, for Z6 minus C6, here we will have -1 into 0 plus 3 into 0 plus 0 into 1 minus the value of C6 is 0, and finally the value of Z6 minus C6 will be 0. So, in this row, here we will write 0. So, we have found out the values for Zj minus Cj, and filled up this row. Now, if we look at the values of Zj minus Cj, all these values are either greater than 0, or equal to 0. There is no negative value of Zj minus Cj here, since all the values of Zj minus Cj are greater than or equal to 0. That is, they are all positive values. So, we can say that our solution has reached the optimal stage, and we don't need to make any more new tables. Finally we will write, since all values of Zj minus Cj are greater than or equal to 0, the solution is optimum. Then we will write the values of x1, x2, and x3 from the basic variables. Here we can see that value of x1 is 4, value of x2 is 5, and there is no x3. So we write x1 equals to 4, x2 equals to 5, and x3 equals to 0. Now, we will write, the optimal solution is given by max z dash. If we see, in the question we had minimized z, but in our standard LPP form objective function we had converted minimize z to maximize z dash by multiplying -1. So, we will calculate max z dash here. After that we will multiply value of max z dash with -1, which will convert max z dash into minimization function again. The formula of max z dash will be CB into XP. Now we will multiply values of CB with XP, and then we will add them. In CB column here we have -1, 3, and 0, and in the XP column we have 4, 5, and 11. So, we will write CB into XP equals to -1 into 4 plus 3 into 5 plus 0 into 11. The answer will be 11. Thus, the value of max z dash is 11. Now, we will find out minimize z. We know mean z equals to -1 into max z dash. So, we will multiply -1 with the value of max z dash, which is 11 to get mean z. So, optimum value of minimize z is -11. So, in this lecture we have solved a minimization problem by Simplex method. If this video was helpful, give it a thumbs up, subscribe to Academic Gain Tutorials on YouTube, and share in your learning circle. Thank you.